Welcome everyone, still on question in motion. We have a question here that says, a train starts from rest from a station and travels with uniform acceleration 0.5 meters per second for 20 seconds. It travels with uniform velocity for another 30 seconds. The brakes are then applied so that the uniform retardation is obtained and the train comes to rest in a further 10 seconds. Sketch the velocity time graph of this motion. Using your graph, calculate the total distance traveled by the train. First and foremost, to sketch the velocity time graph, the vertical axis represent velocity. Let's have that line to represent the vertical. And we have the horizontal to represent the time, T for time. And then we have V, meters per second. Let's start. The question says, a train starts from rest from a station and travel with uniform acceleration. The slope of a velocity time graph represents the acceleration. And we have the slope there. That represents the acceleration. That is given as 0.5 meters per second. That was done, accelerated for a period of 20 seconds. It travels with uniform velocity for another 30 seconds. Maintain uniform velocity. The horizontal line in velocity time graph represents constant or uniform speed velocity. Further for 30 seconds. 30 plus 20 will give you 50. Then the brakes are then applied so that the uniform retardation is obtained and the train comes to rest in a further 10 seconds. Now we have this negative slope represent retardation. For that 10 seconds, 10 plus 50 will give you 60. Remember, this horizontal line represents the uniform velocity or speed. We represent that as V naught. Then this is how the velocity time graph will look like. That's how it will look like. Use your graph, calculate the total distance travel. In velocity, in speed time graph, velocity time graph, distance is the area of the graph. And this graph here, the area of this graph is have the shape of a trapezium. That's the shape of a trapezium. So the area will be half A plus B and height. A is the smallest side. This is the smallest side. B is the longest side here. H is the height. We have the height here, H. But here the height will be given if we can obtain V. Now let's extract the data here. A is the smallest size, that is 50 minus A is 30. B, the largest, B is 60. The height, let's find V. The slope of a velocity time graph, we don't know the height for now. Let's look for V. The slope of a velocity time graph acceleration, that is V2, using the expression all over T2 minus T1. In this regard, V2 represents the V naught there. And then V1 here, 0. T2 is 20. T1 is 0. We end up having A is equal to V naught all over 20. And remember that our A was given as 0.5. 0.5 is equals to V over 20. That is A. We make V subject of formula as 0.5 times 20. We end up having 10 meters per second. That's the speed. Getting the speed means that we have obtained h, which is 10. I remember with 10, h was unknown here. Now we have to go back to the expression, this expression here. We're looking for the distance. D is equals to half a plus b h. Substitute the value. A, we have A to be 30 and B given as 60. H calculated it, that's 10. If we do that, the distance, we have the distance, give us the distance to be 450 meters. That will be the distance, 450 distance. So in this question, the distance, calculate the distance travel, the distance is 450 meters.